be simplifying radicals with variables. And I know oftentimes variables make things harder, but in this case, they don't. The variables are actually kind of like easier, I would even say. Okay, so here are your examples. I'm just going to do 2 examples, and you are going to be ready to try this out because you're going to see it's like the content, but almost like without the math. So here's your first one. N to the 4th, P to the 3rd. Okay, so you know what we're doing? We're doing the same thing that we were doing. So first I'm going to prime factor this number. Now what that means is I'm going to take this, I'm going to break it down into its factors. And here's what the factors are. N times N times N times N, that's what N to the 4th means. And P times P times P, because that's what P to the 3rd means, right? Now, same as when I'm simplifying radicals, right? I'm going to look for doubles. So I have a double N, a double P, and a single P. So this double N goes in its own house, this double N goes in its own house, this double P goes in its own house, and this single P goes in its own house. Now, remember, doubles simplify. Think about what this means. This means N squared and square rooted. Well, we know that square and square root are opposites. They're inverse operations. They undo each other. No matter what this number is, right? Like, see these 2 are going to undo each other, the square root and the squared, and it's going to simplify to N. Okay, so this square root of N squared becomes N. This square root of N squared becomes N. This square root of P squared becomes P, right? And we're all just multiplying. And then this, okay, this is the square root of a number, right? But we don't know what the number is, and so it doesn't simplify, right? Like this does simplify. Like no matter what this number is, let's say it's 7. This is 7 times 7, that's 49, and the square root of 49 would be 7. So no matter what this number is, what N is, it would, like the square root of N squared would always simplify to this. So then I rewrite this in simplest form, which is this is N times N, that's N squared, P times the square root of P. And this is done. Sometimes what we have is a mix of numbers and variables. And again, this seems like, ooh, challenging, but no, it's just literally the 2 mixed. So let's start by factoring 50. That's 5 times 10. This is 5 and 2. So when I go to write out the prime factorization, it's 5 times 5 times 2 times A times A times A times A times A. That's A to the 5th, B. Okay, let's find our doubles. Double here, single here, double, double. Notice I have to be neat because I got to catch, right? Look, this is 2 doubles and a single, and this is a single. So now look, each of these doubles goes in its own house. And then the singles, look, the singles are going to go all together. This is the singles house. Okay, this simplifies. This is the square root of 5 squared, that becomes 5. This is the square root of A squared, that becomes A. This is the square root of A squared, that becomes another A. Let's just be lazy and write it like this. And then this does not simplify. And that's it. Okay, now notice if it was just 50, it would just be 5 root 2. And if it was just A to the 5th B, it would be A squared, square root of AB. But I can combine them and it looks just like this.